Hello, welcome to my talk on the Atom Precovery service. I'm a software engineer at Asteroid Institute, and I work on Atom, which is a cloud-based platform that hosts a number of astronomical tools, including the Precovery service that I'm going to talk about today. So very briefly, Precovery is the process of searching for images taken before an object was discovered. And this is done to extend the arc of those objects and improve their orbits. One brute force method for this, if you imagine having a data set, is to take your orbit and propagate it back to every time within that data set, and then check that against every observation of every object there. However, as you can imagine, this is very time consuming, and most of those observations are going to be nowhere near the orbit. So instead, Atom's Precovery service divides the sky into heliopixels, pixels, which are then grouped together in the same heliopixel pixel and same time. So these observations are stored in a byte file with an index to make it very fast to access those. And then the orbit is propagated back again to every time within the data set. However, now only those corresponding heliopixels pixels are pulled and the observations within them checked against the orbit. To further speed this up, we use n-body propagation to the midpoint of a window, usually 7 days, and then 2-body propagation to go and find those heliopixels. And then, of course, we switch back to n-body propagation as we're actually comparing observations to the orbit. So to get to the results, this is a working service that you can use. And for one example object, in this case, 2011 CM42, running this on the full 7 years of the NSC dataset takes about 35 seconds. We also ran the full 1.2 million small bodies in the MPC catalog on just 4 months of the NSC dataset, and that took about 72 minutes. Whereas, however, the brute force method previously took 26 hours to run just 1 month. We also have a cutout service that allows you to view the images that were found, and I'll get to this more on the next slide. And again, this is a working service. You can try this out for yourself there at atom.b612.ai. So here's one other example, and this is the cutout service you can see below. The crosshairs show the position predicted for that object to be, and you can see also the direction that it should be going in if the exposure is long enough to see a trail. And this is one example object that we found using our linking algorithm in the NSA data, 2013 RR165. The initial arc was 6 observations spanning 9 nights. However, after running it through Precovery, it was able to find another 19 observations and extend the arc to 495 days. So that's a kind of best case example. However, we ran this on all of the objects found using the Thor linking algorithm. And out of the 113 ultimately submitted as new asteroid candidates, 101 of those had their arcs extended using this Precovery service. And that average arc extension was 30 days. So finally, new data sets are being added all along. The current one is the NSC DR2 catalog. However, we're working currently to add ZTF, SkyMapper, SDSS, and more. And the progress of that can be found here at this repo. So that's my talk. And if you have any questions, feel free to email me or any of the other people listed in this slide. Thanks.